Daily work unit 4.1. Given that this is a parallelogram, we'll answer the questions. And what we're going to find is sometimes instead of going from 1 to the picture and 2 to the picture and 3 to the picture, it's easier just to solve the picture and then answer all the questions. So we'll do that. We know that if this is a parallelogram, then opposite sides are equal. So if this is 12, then it's 12 up here. We know that the diagonals bisect each other. So if this is 5, then this is 5. If this is 8, then this is 8. And that's all we can do with the number. So let's go ahead and take care of that. EF is 12 because opposite sides of a parallelogram are equal. QF is 8 because the diagonals bisect each other. AE, this whole diagonal, is the sum of the two pieces. If one piece was 5, the other is 5 because the diagonals bisect each other. Therefore, the whole diagonal is 10. EQ, Q being the center, was 5 because that was 5 and the diagonals bisect each other. So we took care of all the sides it asked for. We kind of clean house a little bit there, and then we will deal with the angles. Now we know that if it's a parallelogram, then opposite sides are parallel. We could signify that with single arrows on one of the pairs of sides and double arrows on the other. Remember, if lines are parallel, then alternate interior angles are equal. Corresponding angles are equal. Same side interior angles are supplementary. And if a transversal was perpendicular to one of two parallel lines, it would be perpendicular to the other. So if this angle is 50, then this angle down here is 50 because alternate interior angles are equal. Just like those were alternate interior, I could go from E to F diagonally across to G and over to A, and I see a Z that way. So those are alternate interior angles. The lines that form them are parallel, so this angle down here is 30 degrees. Now I know that the sum of the angles of a triangle is 180 degrees. So if I add up the 50 plus 30, I get 80. Subtract that from 180, and I'm going to get 100 degrees for that obtuse angle. Now, if that angle is 100 degrees, then the one across from it is 100 degrees because vertical angles are equal. This other pair of lines is parallel, and so I could see alternate interior angles going across my other lines. So if that angle is 60, then this angle is 60. I know that a straight line is 180 or a linear pair is 180. So if I looked at that linear pair I just drew in red, then I could say 180 degrees minus 100 degrees is 80 degrees for that angle next to the 100, adjacent to the 100. And then in this little triangle here, I know that its sum is 180. 80 plus 60 is 140. Subtract that from 180, and I'm going to get 40 degrees for the angle in the corner there. Now, if that one's 40, then this one over here is 40 because alternate interior angles are equal. And this angle is 80 because it's vertical to the other 80. So using alternate interior angles are equal, the sum of the angles of a triangle is 180. A linear pair is 180. vertical angles are equal, consecutive angles are supplementary, opposite angles of a parallelogram are equal, we can figure out every single missing angle measure. Now, it's a little bit hard to see there, but you can recreate that yourself there. And so we see that angle EAF, that's this angle from here to here to here, E to A to F, was 60 degrees. Angle EAG, that's from here to here to here, EAG, was 50 degrees. And you can figure out the rest. That gives you an indication of how we got all of those angles, okay? I'm going to leave the next one for you to do. You need that experience. Draw and label the example accurately. We wanted AB. And I'm going to try something just a second. If you bear with me there, I'm going to take a little tool here and I'm going to take a snapshot tool, and I'm going to take this little question, and I'm going to try to copy and paste that into a Smartboard document. Let me drop that down. That's not really where I wanted it in that one. I'm going to minimize here. I'm going to pause. Okay, so we're back. We took that question, we snapshotted it, which copied it. We pasted it into a Smartboard notebook with a protractor and ruler, and we're going to try to do a little bit better job of maybe showing you how to draw these. Now, I want an imperial ruler. It says, well, it said 1.4 centimeters. AB, it's got ABC at 105 degrees, and BC is 1 7/8 inches. So we'll just start with the 1 7/8 inches. The angle at B is 105. So I'm going to draw BC to start with. And so I'm going to grab me a pen. Hopefully I can do some kind of a decent drawing here. 1 7/8 inches, we would start here. We're going to go 1. There's 1/8, 2/8, 3/8, 4/8 is a half, 5/8, 6/8 is 3/4, and there's about 7/8. So we've got 1 7/8 inches. I may have overshot it just a little bit, but you get the point. 1 7/8 is that mark right there. Okay. Then what I would want to do is I would want to set my protractor. Come here, protractor. I would put the bullseye right there, and then I would want to line the 0 up here, which I've done. You see the little bullet there? And your protractor may be a little different. We want to go to 108 degrees, and so I'm going to click on the pen, and I'm going to follow this around to 105 degrees, excuse me. I'm going to follow this around to 105, and I'm going to make a little dot. I'm going to move my protractor out of the way, and I'm going to get my straight edge there. Now, this is where it gets a little bit tricky. And I'm actually not going to get a straight edge. We'd get a straight edge and line it up, and I'm just going to kind of shoot at it here. Actually, I'm going to fudge. Maybe I can pull this in and just kind of draw from here. I would use a straight edge, and I can just kind of shoot it out that way. Now, that's taller than I needed, but I got my angle right. And so then we want to measure this way 1.4 centimeters. So we're going to go back and we're going to grab our ruler, and I'm going to change it to metric. And I'm going to try to slide this thing to where that is setting on, the 1. This is a little tricky here. It may not let me go that high. Well, anyway, what we would do, it won't quite go. I'll just do it from here maybe. See if I can spin it. I'll just try to line this up on a mark. I've got it on the 11. We'll just mark from 11 on. We want 1.4 centimeters. Now these big guys are centi, and the little bitty guys are milli, and it takes 10 milli to make a centi. So we would go 1.1, 2, 3, 4, and make a little mark. 1.4 centi. And so then we would want to measure this angle. Now, if this angle is 105, then the other one is 105, 180 minus 105, which is 75 degrees. So we could bring our little protractor up here, spin it around, and measure. It's a little bit tricky, isn't it? Oops. That wasn't very smart, was it? I've got to line it up. There we go. This needs to be lined up with the little line 0. I'm off just a hair here maybe. With my protractor, I've got to try to spin it. This is a little bit challenging, you can see, to try to do. I'm going to line that up. And then I'm going to try to measure from here 75 degrees. So I'm going to get ready to make a mark. I'm going to go 0 over to 75. And I would make a mark over here. And then I would move all that out of the way, and then I would draw across there. And you can see I'm off a little on my measuring. And then you'd come in here and zip that side in by measuring again. So you can kind of see how we're using the compass and the protractor and the ruler to try to measure, okay? All right. Just wanted to slip one in there and show you. I'll probably hand draw these from now on. Just hand draw a protractor and a ruler, but just kind of want you to see one the fancy way. So you'll draw those, and then you'll label that. We actually wouldn't accept something that's thrown together like I just did it on your homework. If you're in my class, it has to be done properly. So this is 105 degrees. This is 75 degrees, 105 degrees, 75 degrees. This was our B. This was our A. This is 1.4 centimeters, 1.4 centimeters. This is 1 7/8 inches. This is 1 7/8 inches. This is the C, and this is the D. Okay, so you're going to precisely measure the way I showed you with a visual protractor and ruler. Okay, and then you can do the next one on your own. Okay, number 21. So we had a couple of drawing things. Number 21 we want to deal with, and we want to talk about number 23 also, because we're going to use some of that factoring quadratic stuff there. Number 21, in parallelogram ABCD, opposite angles A and C take up a total of 60% of the parallelogram's interior angle sum. Well, what is the interior angle sum of a convex polygon? Well, the interior angle sum formula is the number of sides minus 2 times 180 degrees. If we're talking about a parallelogram, we're talking about 4 sides, so we would have 4 minus 2 times 180 degrees, which would be 2 times 180 degrees. And so the interior angle sum is 360 degrees. If angle A and C take up 60% of it, that means that B and D take up the other 40% of it. 60% as a decimal is 0.6. 60% of 360 would be 0.6 times 360. 0.6 times 360 would be 216. If we divide that by 2, we get 108 degrees apiece for angle A and angle C. And we'll leave you to find angle B and D. Okay? So we needed to recall the interior angle sum of a convex polygon formula n minus 2 times 180. And how to find a percentage. You take your percentage as a decimal times the whole, and you get the part. In the Algebra 1 textbook, on page 62, we talk about part is equal to percent times whole, part equal percent times whole. Okay? All right, let's take a look at number 23. It says in parallelogram QRST, angle Q is 3x squared plus 5x minus 8, and angle S is 2x squared plus 3x minus 5. Now, angle Q and angle S are opposite angles. If we were to draw QRST, we would have to go in order QRST, so that shows us that Q and S are opposites. Now, we really don't know if they're the two big ones or the two little ones. We'll figure that out after we solve. But we do know that they're opposites, and we know that opposite angles of a parallelogram are equal. And so we can set them equal to each other. Angle Q is equal to angle S. Therefore, the measure of angle Q, 3x squared plus 5x minus 8 degrees, is equal to the measure of angle S, which is 2x squared plus 3x minus 5 degrees. Now, when we solve quadratics, remember that a quadratic is of the form ax squared plus bx plus c equals 0. That's on page 194 of the algebra text. On page, I believe it's 223 of the algebra text, we discuss quadratic word problems. And what we say there is, to solve a quadratic by any method, we must first set it equal to 0. Set it equal to 0, because setting it equal to 0 is putting it in standard form. Now, the quadratic on the left, 3x squared plus 5x minus 8, is not set equal to 0. It's equal to 2x squared plus 3x minus 5. Now, to make that a 0, we need to zero out the right side by using the additive inverse of everything there. That makes that cancel, cancel, cancel. We created additive inverses, which creates a 0, 0, 0, and so we've zeroed out the right side, if you will. We set it equal to 0. What you do to the right side, you must also do to the left to balance it, and we're going to line our pieces up under like terms. And when we combine our like terms, we would have 3x squared minus 2x squared would be 1x squared, and 5x minus 3x is 2x, and negative 8 plus 5 is negative 3. So now we have a new quadratic that is set equal to 0, and we're just going to solve by factoring. It's not hard to solve by factoring here because the a is 1, the b is 2, and the c is negative 3. Factoring is easier when a is 1. When a is 1, we want to think, what can I multiply to get C and add to get B, and the numbers would be a 3 and a negative 1. When you multiply 3 and negative 1, you get negative 3. When you add 3 and negative 1, you get positive 2. And so this quadratic will factor into x plus 3, x minus 1. You still need to know how to use the whole AC method on page 213 of the Algebra 1 text. Just in the geometry text, we're trying to focus on geometry and brush up on some of the basics of algebra. So many times here, we're giving you an A of 1 so you can get good at that shortcut method. Now, this isn't any solutions yet. What we need to do is find the value of x and plug it back in to solve for q, or plug it back in to solve for s, but we've not yet even solved for x. We know that if two factors have a product of 0, then either the first factor, x plus 3, is equal to 0, or the other factor, x minus 1, is equal to 0, or they're both 0. So to solve, we're going to subtract. We would get x is equal to negative 3, or here we add 1, and we get x is equal to 1. So we get x equal negative 3 or x equal positive 1. Now, we don't really know which one it is yet. You may think, well, you can't have a negative answer. You can't have a negative answer for distance or for length or for angle measure. But x is just a variable that's a part of that whole degree. So we have choices of what to plug in for x to find our q and our s, and we will plug them both in and take whatever is acceptable. So I'm going to get rid of that, and we're going to focus now on our choices for x of negative 3 or positive 1. So we'll try out angle Q. Angle Q, it said, was 3x squared plus 5x minus 8. If we plug in the negative 3, then we would have 3 open negative 3 quantity squared plus 5 times negative 3 minus 8. So we would have 3 times 9. And 5 times negative 3 is negative 15 minus 8. And so we have 27 minus 15 minus 8. 27 minus 23 is 4. And so angle Q would be 4 degrees. Now, we know that angle Q and angle S are equal, so that would be 4 degrees for each one. Now, let's plug in the 1 and see what we get. If we plug in the 1, then we would have 3 times 1 squared plus 5 times 1 minus 8. So 1 squared is 1 times 3 plus 5 times 1 is 5 minus 8. So we're going to get 3 plus 5 minus 8, which is 8 minus 8, which is 0. The length of a side can't be 0, so or the measure of an angle can't be 0. And so it has to be 4 degrees. So we're talking about a very, very whomper-jawed rectangle. And we know that consecutive angles are supplementary, so 180 minus 4 degrees would be 176 for angle R, 176 degrees for angle T, and angle S would be the same as angle Q, 4 degrees. Any questions on that? Okay. That's the end of daily work 4-1.